Let's pull back the curtain on a hidden chemical powerhouse, a substance that is, quite literally, the secret architect of our entire high-tech world.
I want you to just think for a second about the device you're watching this on right now. I mean, it feels so sleek, so precise, right? But what if I told you its creation absolutely dependent on a fiercely corrosive and reactive liquid? It sounds totally backward, but that's the secret behind how these modern marvels are actually built. So, here's a fun one. What could an electric car, a computer chip, and, of all things, fertilizer possibly have in common? They seem like they're from completely different universes, but believe it or not, there's a single powerful thread that connects them all.
Well, the answer is a single and, surprisingly common chemical, nitric acid. It's the true unseen architect of our modern world, shaping everything from the food we eat to the technology we can't live without. All right, so before we get into all the crazy things it does, we've got to understand what this stuff is. What gives this one chemical its incredible power and its versatility? So the formula is HNO3. And yeah, as a mineral acid, it's highly corrosive. But its real superpower is that it's a strong oxidizing agent. Now, what does that mean? Basically, think of it as being super generous with its oxygen atoms. It aggressively shares them to break down and react with other materials. It's that reactive nature that makes it such an amazing tool for industry.
And since it's so important, you can bet we make a ton of it. The process is pure genius. We're literally turning the air we breathe into this incredibly powerful acid.
This is all thanks to something called the Ostwald process, a Nobel Prize-winning breakthrough from way back in the early 20th century. Its efficiency was a total game-changer, and it blew older, energy-guzzling methods out of the water. And get this, it's so effective, we still use the same fundamental process today to crank out millions of tons of nitric acid every single year.
It's this really elegant three-step dance. First, you oxidize ammonia with a catalyst to create nitric oxide. Second, that nitric oxide reacts with more air, and it becomes nitrogen dioxide. And finally, that gas gets absorbed into water, creating our nitric acid. But here's the really clever part. That last step also creates some leftover nitric oxide, which gets immediately fed right back into the second step. It's this brilliant, self-sustaining loop that makes the whole thing so efficient.
Okay, so let's circle back to where we started. Your phone, your computer. How on earth can you use a corrosive liquid to create something as unbelievably delicate as a computer chip? Well, the answer is all about precise control. This analogy just hits the nail on the head. You have to stop thinking of it as a destructive force and start seeing it as an artist's tool. See, chip manufacturing isn't so much about building up as it is about carving away. And nitric acid is the chemical chisel they use to sculpt silicon at a scale that's almost impossible to imagine. So nitric acid really has two main jobs here, etching and cleaning. For etching, it selectively dissolves these impossibly thin layers of silicon and metal to create billions of transistors and the tiny circuits connecting them. But just as important, it's also the world's most effective janitor. Its oxidizing power can wipe out any microscopic speck of dust or oil that could completely ruin the chip.
But, and this is the part that just blows my mind, after all this talk about high-tech gadgets, it turns out that's just a tiny, tiny fraction of where this stuff goes. The vast majority, we're talking around 80%, is used to create ammonium nitrate. And what's that? Oh, just the key ingredient in modern fertilizers. So yeah, the same chemical that powers our technology also feeds the world. Just wow.
Okay, but let's go back to that small slice of the pie used in electronics, because that specific application has one absolutely non-negotiable requirement, an almost unbelievable level of purity. When you're making a microchip, close enough is a recipe for absolute disaster. And that really makes you wonder, right? When you're working with components that are measured in nanometers, what does clean even mean? The level of purity they need is just staggering.
So, get this. In a normal lab, you'd use something called reagent-grade acid. Impurities there are measured in parts per million. For microchips? No way. That stuff is thousands of times too dirty. They need semiconductor-grade acid, where impurities are measured in parts per trillion. To put that into perspective for you, the difference between a million and a trillion, it's like the difference between 1 second in 12 days versus 1 second in nearly 32,000 years. That is the mind-boggling level of purity we are talking about.
And there's a really good reason for that obsession. A single stray iron ion can disrupt a transistor and cause it to fail. A tiny dust particle can block the etching process, creating what they call a killer defect on the chip. Any microscopic contaminant can ruin a batch of chips that's worth millions of dollars. You can see why purity is everything in the semiconductor industry.
So nitric acid is a true hidden giant, shaping our world from the farm all the way to our phones. It kind of begs the question, doesn't it? As our technology continues to get smaller and more complex, what other unseen architects are out there, just waiting to build our future?